Hi, folks. Um, Good evening, good morning, whatever time of the day that you've got. And I'd just like to put a disclaimer in here. Not all people who are watching this have been students of mine, so you may have been taught this in a different way. I'm sure that's fine, but this might just be supplemental to your learning, and just take from it what you will. So we're going to talk about things called ratios, sometimes called ratios in proportion. So what is a ratio? Well, it's like it's saying here, it's a comparison of two or more quantities. If it was just two, it'd be like a fraction. So I'm just going to go have a wee example here. So there's a comparison of 2 parts to 3 parts, a ratio of 2 parts to 3 parts. And sometimes the way they write it is 2 parts to 3 parts. It's 2 ... 3. So we're just going to go for an example here. So some drink is mixed in a ratio of 3 parts concentrate to 7 parts water. So water to concentrate. Okay, we've got a mixture here. 3 parts concentrate to 7 parts water. So next part is, so this is a recipe, 3 to 7, 3 to 7, that's a recipe. Next part is, they're giving us some amount of concentrate, 210 millilitres, and they want to know how much water we need. In order that the recipe rules are fulfilled. So, just in case you're wondering, they're saying here concentrate is juice, but it's not exactly juice, but they extract the water, because taking too much water adds on too much weight. So concentrate doesn't mean think hard. Something like that there. You might call that diluting juice. I don't know. Concentrate. The juice element has been concentrated. Okay. Let's go back to the question. So we'll get this ratio of 3 parts concentrate to 7 parts water. 3 to 7. That's overall. 3 plus 7 is 10 here. So if we had 3 pints to 7 pints, that'd be 10 pints in total. Bear that in mind. So this question here, we're talking about milliliters here. So we've specified concentrate in two of the parts. We've only got 1 part for water, but that's what they're asking for here. So we get 3 out of the 4 parts. So the way I'm going to set it up is I'm using C for concentrate, W for water. So C2W. So put in the ratio numbers, 3 parts concentrate to 7 parts water. So we've got one other additional bit of information. So was it concentrate or water? It was a concentrate. It was 210. Okay. So it looks like we've got 3 out of the 4 elements here. Right, before I do that, I just want to highlight we got 1, 2, 3 things, we are looking for a fourth item here. Okay, that's what we're looking for. So this is going to be a recipe to get as a fourth. So what we're going to do here, because in this column here, we know the two things. So we're going to use these two in order to help us to get the fourth. So what we're going to do here is the 2, 10 and the 3. I usually got the way. I'm going to take that and divide it with that. So 210 divide by 3, okay, what does that give me? 70. And so because I'm dividing that side, I'm going cyclic. And this is basically like an equation. So on this side, because I've divided here, so I need to do the opposite here. So the 7 times the multiplier. 7 times 70 is, what is it? 490 milliliters. Okay. So here, so we need to make a statement here. We need to use 490 milliliters of water. So in this method I'm using here, I don't like to put in equal signs and stuff like that, but these colines are effectively equal signs. Okay, let's move on. It doesn't matter the topic I'm touching upon here. It doesn't matter what course you're on. Just go with the story. See how it goes. So a metal alloy, whatever it is, it's a mixture of metals. So 6 part copper to 5 parts zinc. So first part was information, second part is more information. So if we get 40 kilograms of zinc, how much copper do you require? So we'll get 3 or 4, so we get 6, 5 and 40. Let's see how we go. Let's set it up. So I've highlighted stuff here. I like to highlight stuff. So let's set it up. Copper to zinc. So I'm using C to Z. Information, ratio information. 6 to 5. And they've given us either copper or zinc in terms of weight or mass, whatever you want to call it. We get 40. Okay, so we have got one, two, three out of the 4. So we're looking for this one here. Okay, so on this side we're going to use these two in a circle to get this one. So we take this side, the 4 and the 5, and we're going to go up the way, then across and down. So we take the 40 divided by 5. What do you get? 8. On the other side, opposite of divide is multiply. That's what we're going to do here. So 6 times 8 is 48. So that means we need 48 kilos of copper to make the alloy. Okay, let's move on. We're going to do things a little bit differently here. So just you have a little read of the question. We've got 30 engineer students. They're splitting the ratio of 2 females to 3 males. Right, but it's 2 to 3. And it's F to M. That's the letters I'm going to be using here. Right. Then the question is, how many female students are in the group? Let's progress. So I'm using females to males. Whatever, I was just F to M. Okay, that's the ratio 2 to 3. But with some other piece of information, with the total number of students is 30 here. So this is going to be slightly different from the last examples. So how we tackle this one is ANS means the answer. We're going to use a fraction here, and up the top, that means number of interest. Below, that means the sum of the ratio. This is a ratio, so the sum is adding these two together. Then we're going to times it by the total, so fraction of the total, and we've got a total there. Right, okay. So number of interest is 2, the females. The sum of the ratio, 2 and 3, add them together, times the total, the 30. Okay, I think we can sort out at the bottom of the 2 and 3 there to get 5. So it's 2 over 5, 2 divided by 5 times 30. Or you could do it in your head. So what's that going to give you? 12. So that means it's 12 females within the group. Okay, let's move on. Some other bizarre topic here. You can have a little read of that. Box of chocolate split into the ratio 3 parts dark chocolate to 4 parts milk chocolate. There's 42 in total chocolates in the box. How many dark chocolates are there? Right, so here we've got dark and milk. We've got a total of 42, but then they're asking for how many dark there are. So let's set this up. So I'll probably use D and M. Okay, and we've got a total here of 42. Let's see how we go. So 3 dark, 4 milk, or whatever they like to call it, and we've got a total of 42. Right, but we want to know how many dark there are in the entire box before someone is eating them. So let's go for the answer, ANS answer. So it's the number of interest over, like I'm saying here, over the sum of the ratio. Just to be explicit here, so you know what they are. So that's a fraction times the total. That's what we want here. So let's set up the ratio. Dark to milk, D to M. So we had, what was it, 3 to 4. Okay, that's right. And I think we've got a total. I think we've got a total of 42. That's okay. Right, so the number of interests, what are we interested in? It was a dark. Okay, we were interested in that, so that's why we've got a 3 there. And sum of the ratio, that's a 3 and 4. That's why we'll get that there. Okay, so that's a fraction of the total, so it's times the total of 42. So 3 divided by 7 times 42. You can do this various ways. Use your calculator. 3 divided by 7 times 42. So you get 18 dark chocolates. Fantastic. Okay. What about milk chocolates? Several ways you can do this. You can either go through the same process, but this time 4 would be the ratio number, the number of interest. You could put that in, times 42, and you get 24 milk chocolates. You could have done that. And let's add them together, 18 dark, 24 milk, 42. So it seems to confirm that that was a total in the box. Okay, let's move on. We're going to be chopping and changing throughout this little lesson here. It's not going to be in that linear format. I'll be changing things, and then I'll be going back to begin and change things again. Then go into chapter 2. So, let's talk about proportion. Okay, we're just talking about two quantities here, it could be three. And it's one of the increases, the other one may increase in relation to it. So, like, think about like maybe currency, pounds to dollars, pounds to euros. So as one goes up, the other one goes up, and one goes down, the other one goes down. Okay, one goes up, the other one goes up. As one goes down, the other one goes down. Right. So money is actually a good analogy story to represent this. So that's my favourite top, my t-shirt. So, and that t-shirt actually costs £6. And on the same day, how much would two t-shirts cost in the same store regardless of discounts? Yeah, how much? Fun, you know. Just 2 times it? Yep. What about 3? 3 times the initial? Yes. And what about 10? So hopefully you're thinking 10 times the initial amount of 6. So what's 10 times 6? 60. Oh, let's change it. What about 5? 5 times the initial amount? 30. So hopefully you're getting the gist of this here. It's just the unit cost times whatever the amount is there. So that's what we're getting at there. Okay, so let's go for another example. So it costs £6.90 for 3 pints of real ale. I don't care what real ale is, really, or real ale. So that's these things called real ale. It's like a jug of chocolate with a lemon mousse topping. So £6.90 for 3, identical. How much would it cost for 7 pints? Oh, they're changing it here. So you've got that information to start with. So how much is it for 7? There you go. Again, there's various ways to think about this. So I'm using P for pints or portions, whatever, is £6.90. That was initial information. So I think, see if we could break it down to 1 unit. How much would 1 unit cost? £2.30. How does it get £2.30? Maybe divided that by 3. Divided that by 3. We'll see. And then 7. Maybe multiplied up by 7. Let's see. Okay. So divide that by 3 to get 1 unit. Okay. On the other side, we do the opposite. Or do the same, sorry. Sorry. We divide that by 3. So that gives us 1 unit, 1 portion, 1 pint, whatever they want to call it. But we want 7. So going from 1 to 7, we don't add 6, we multiply. To get 7p. On the other side, the 230, we multiply that by 7 to get 1610. So hopefully that makes sense. Sometimes your brain actually does it for you, and you don't think about algebra or equations. Your brain sorts it out for you. Okay, so then just make a little statement. So 7 pints or portions, whatever they're talking about, would cost £16.10. So here, without the multiply, divides either side, that's what we did. Bingo. Okay, let's change tact here. A plane traveling at a constant velocity, well, velocity is just speed in a certain distance, a specified distance, so it doesn't matter to us here. We've got a distance here and 45 minutes. So what's the question? How far can it travel in 405 minutes? That's good that we're operating in minutes and minutes here. So we don't need to change units. Right. Okay. So how far? So we're talking about kilometers for how far. Let's set it up. M for minutes, K for kilometers here. So I went 45 minutes down to 1 minute. I must have divided that by 45. Okay, so I need to divide that by 45. Yep, to get that there. And then, so the number of minutes I want to go to is 405. So I must have went from there to there by multiplying for 405. So I need to multiply this by 405. And that's exactly what I've done. So there you go. So I've not put in any real workings. Hopefully you can follow. 45, we divide it by 45 to get 1, then we multiply up by 405 here. So what we do on this side, we do exactly on that side. Okay, 45 divided 1, so 720 divided by 45 to get that. Then we multiply that up by 405. That's what we've done there. Okay, this is us going back to the examples that we looked at the start. As I said, we chop and change things to confuse you or encourage you. Okay, we've got these 3 people, Danuta, Paulina and Svetlana, and they inherit a certain amount, £30,000 between them. This is split in the ratio 3 to 5 to 2. That ratio order is important. It's in order of their names that appear above. So, Danusha, Paulina, Svetlana. Okay, Danusha, Paulina, Svetlana. Okay, and the question is, we always need to have a question. Question's always at the end. The other 2 parts are information. How much do each of them receive? So, I'm just going to use, because their names begin with different initials, I'm going to use those 3 initials, DPS. Okay. And table would be associated with 3, 5, 2. So D with 3, P with 5, and S 2. Right. So this is going to be the fraction of the total. So the amount, whatever it is, fraction of the total, is the number of interest, okay, the ratio number of the sum of the ratio, we had 3, 5, and 2, times the total, that was the amount of money. And we've got 3 people here. But the thing is, for each of them, the sum of the ratio, because we had 3, 5, and 2, it's 10. Please take that on board. 3, 5, and 2 is 10. Look to previous page. Times the total. So that stays the same regardless. So D for Danusha, P for Paulina, S for Svetlana. So it's only the top numbers here. These are identical. So it's Danusha, so it was that 3, 5, 2. I think that was the order. I've got quite a good memory actually, so yes, it is. So 3 divided by 10 times 30,000, 5 divided by 10 times 30,000, 2 divided by 10 times 30,000, let's see, 9,000, 15,000, 6,000, they're all in pounds. So they look like nice numbers. So does that seem okay? Well, the 5 seems the biggest ratio number, and 15,000 seems the biggest amount. So that 2 is the lowest number, and 6,000 is the least amount. 3 is in the middle-ish. So 9,000 is the middle-ish number. How can we check that this might be okay? 9, 15, 6,000. Why don't we just add them together? Yeah, let's add them together. We get 30,000. And that was the inheritance amount. So it seems to check out there. It's always a good idea to do something like that at the end. And the numbers will not always be as nice as this. And yet again, if you've got a different little method that your lecturer might have shown you, do that. Okay? I don't want to confuse you. Okay. I think this will be the final one here. So we've got 3 people, Alan, Zach, Gina. They work different hours for a company in the same week. Okay, information. 3 people. And it's in the ratio 2 to 3 to 4. That's nice. And so it'll be in that order. Alan, Zach, Gina, 2 to 3 to 4. That's important. So if Gina works 36 hours in a certain week, how many hours do Alan and Zach work? Okay. Right, so we know about one of them. Right. Let's set up a ratio here. Alan, Zach, Gina, AZG, Alpha, Zulu, Golf, whatever you want to say. Here's the ratio numbers, 2 to 3 to 4. But we've only got, I think we've got one piece of information, and that was about Gina, 36. I don't need to write in hours here. We know the context, we're talking about hours. But the thing is, what we have got here is these two. So we're going to use these two, and we're going to go up the way. We're going to do 36 divided by 4 here. And that will give us what I'm going to call the multiplier, and I'll use it with both of these. So I'm going to divide 36 divided by 4 to get 9. Other side, I'm going to multiply both of these. 2 times 9 to get 18, and 3 times 9 to get 27. So that means that Alan works 18 hours and Zach works 27 hours. Right. You can always rewind this and see if it makes sense to you. And like I say, your other lectures might do this differently, but we all do things differently. And our brains are all different. So, I'm going to leave that there. So I'll just need to, woof. That's nearly 30 minutes there. So I'm not going to go up to 30 minutes, so I'll just stop that there, folks. So hopefully that wasn't too long. Right, bye for now.